Look at two patterns, the iterator pattern, the observer pattern. I'm going to tell you that these two are very closely linked. They seem very different, but they are very, very closely linked. They're very popular patterns for a long period of time. They were sitting in that book, right? A very old book. For a long period of time, people didn't see the link between the two. Okay. In fact, in that book, or maybe somewhere else, like published soon after, they used to have these pictures of related patterns, right? When you use this pattern, you should probably use this one, right? And they had like this map of where all these patterns fits. And if you look at that map, iterator pattern and the observer pattern are nowhere near, right? It's very far off. There isn't even a link between the two. They weren't even close. But now you'll understand the link. And this is the moment of the click. And this is the aha moment, right? Which a lot of people had at the time. What is common between these two? One is the iterator pattern. The consumer is saying, give me the next item. And the implementer, the iterator implementer, is giving the data. Here, the observer pattern, the observer gives, the consumer gives the observer to the source, and the source says, I have new data, and it gives this data. What's common between the two? Is it inverted? Yeah. Isn't it inverted? It's basically where the data is flowing. Something is sending the data, and some other thing is receiving the data. Right? That's true here. One thing is receiving the data, one thing is sending the data. What's different is not the direction. Well, you flip this thing, the direction is going to be the same, right? Which is what I've done here, right? The direction is the same. But what's different is who controls when it is sent. Okay? Look at this one. When is data sent over here? Data is sent when the consumer asks for next. Consumer says, give me next. The iterator implementer gives the data. Here, who's controlling where the data, when the data is sent? It's the source that's controlling it. The source says, I have new data. You take this data, whether you want it or not, you get this data. You are getting executed, right? So yes, exactly. Push versus pull, right? This is precisely push versus pull. You hit the nail on the head. Here, you're pulling the data. Here, you are pushed the data. Okay, that's really the only difference. These two are probably among the closest related patterns that you can find in the design patterns book. And it took people about 20 years to see that link, right? So the difference is just about when. Okay. So if you look at the iterator pattern, right? An example of an iterator pattern is, print every element in the list. You would do something like this, right? You have a list, and then for each element, I'm going to do system.out.println of that element. Okay. Granted, this is not technically the iterator pattern, but it's kind of using that, right? You're basically saying, the for each is basically fetching the data and then doing, okay, give me next, then it's going to run this. Give me next, it's going to run this. Give me next to run this. And when everything is done, it's going to say my for each job is done and it's going to move on. Right? This is how it's doing it. Now let's look at the observer pattern. Let's say here's the problem we want to solve. The observer pattern is listen to mouse clicks and print each click event. Okay, so you have something like this. Let's say there is a clicks channel, right? Something which is emitting clicks. So what you do is you add an observer to it. It's like you're saying, hey, whenever a click event happens, execute this thing, and you're passing it this lambda, which is saying event system.out.println of that event, right? Yeah, it's basically observer. You're passing it saying, when that happens, run this. Now, I'm going to put these two side by side. Okay? Should make sense, right? They're kind of exactly the same. So irrespective of when the event happens, irrespective of who controls the direction of the push of the data, look at the programming model. It's the same. The syntax is the same. The method name is different, of course. I can call this foo or whatever I want. It really doesn't matter. Look at the programming model. So the aha moment is, irrespective of whether you're iterating on something and something is, being pulled, or you're passing an observer and you are pushed the data, the programming model does not have to change. The programming model can still be the same. And this is the aha moment, which leads to reactive programming. Reactive programming is an attempt to make the programming model for these whole asynchronous, observable, push-pull models, the pub-sub models, kind of applying the same programming model that we are familiar with iteration and with streams, and still make it work. And not only make it work, it makes it so much more intuitive, so much more easy to use that, it beats the whole asynchronous management by a long shot. It makes it so much simpler because this is a programming model we're already familiar with, right? And not only that, you can chain operations as well. Okay, so now that we have moved to this model, think about this. Here is a chain operation where you're filtering all elements which are not null. Okay, so you're iterating over a list, you're printing all elements in a list, but then anytime an element is null, you don't want to print it. You don't want to continue with the next series of operations that happen for each element. You're pulling an element, running a series of operations. At some point in that operation, you're going to go, well, I'm not going to do this operation, the rest of the operations anymore, which is what this is doing, right? Now the question is, can we do this? We're doing an observer, but we are adding an observer not to the main channel. We're adding an observer to a new channel that's created by this filter. Basically, I'm saying for every event that is not null, I want to add an observer. Okay, same programming paradigm. But again, the thing that's controlling it is the other side, but still you're giving it what needs to run and what steps it needs to go through by the same programming paradigm. Right? This is very, very close to the reactive programming syntax. Okay, the actual syntax is super, super duper close to this. So the syntax actually looks something like this, right? The actual reactive programming syntax looks like this. When you have reactive source, you can filter on it, and then you can subscribe to it, which is closer to what we have, right? It's not a for each anymore because it's an observer, right? You're subscribing to that thing. So this is the reactive programming syntax.